This is the measurements lab. Now, because we're doing this by video, we are going to only do each of the trials one time instead of doing it in triplicate. Part of that is because of the size of the video files if I take my time to do all 3 trials carefully. So we're only going to be doing one trial for each one, and then you'll calculate out the results. So in the first part, we're going to look at pipetting and measuring volume. So initially we have to measure the mass of a graduated cylinder. So coming to the balance. The balance says 0 right now, but I always like to tear it out anyway. Tear meaning to make the balance say 0. And then open the door, put the object on the pan, and then we'll wait for the G to pop up in order to record the mass. There's the G. So if there's a little bit more extra water in the last digit, I'll give it a little bit of time to settle down. That looks pretty good, and that looks like the mass that you should record for this graduated cylinder. All right, next we will pipette. Well, next actually we're going to measure the temperature of the water. So here's the water, and the temperature of the water can be read from the thermometer. And I believe that's, let me make sure we've got the Fahrenheit temperature, or Fahrenheit, listen to me, the Celsius temperature. I think that's it right there. Good grief. It's hard to look at this a little bit backwards. But that little, I think that's right. Is that the Celsius? Yeah, that's the Fahrenheit there. So there's a Celsius. So let's read that using correct significant figures. And then you'll be able to look up the density of the water based on that temperature. Okay. Now here's the pipette. As you can see, it's a 10 milliliter pipette. We're going to be using a pipette bulb, unlike the video, for the preparation part of the lab. So to use a bulb, we'll want to squeeze the bulb and put it on the end, and then let up on the pressure to draw the water into the pipette. So initially what we'll want to do is rinse out the pipette with whatever liquid we are pipetting. We have our water here in this beaker. So I will take a small amount. And of course I forgot to bring the waste beaker over here. So that kind of stinks, but we'll swirl that around. I don't want to put it back in because it's going to contaminate my sample, so I'll just use the waste paper basket. Why not? It's been that kind of a day, folks. All right, now I will prepare to fill it above the mark in the neck that indicates that the pipette will deliver 10 milliliters. Okay, so I catch it with either, I'll show you what I did here. You catch it with either your finger or your thumb, and you want the water level to be above where you see the mark for the calibration. So you should do this in a waste beaker, but I forgot to bring one with me to let it drain out. Since it's just water, understand that I'm not really going to contaminate this by doing it this way, but you would want to definitely have it drip out into a waste beaker and not have it remix into your sample container again. So I'm going to let the liquid level drain until the meniscus is sitting right on top of the mark. So if you get it just right, it'll drop at a steady pace and it won't leap and jump for you. If everything is dry at the top, that works better, including your fingers. If your fingers get all a little bit moist, then it's very difficult to control the drop of the meniscus in the pipette. So I get it down to the mark, and we'll stop it there, and you'll see that I've hit the meniscus right on the mark. So then I'll deliver the liquid to the graduated cylinder. We let it just draw out naturally. We don't try and force it out. By gravity, it's just going to draw it out, and it should deliver then 10.00 milliliters within the expected tolerance of the pipette. The tolerance meaning the margin of error. Okay, so then if there's a little drop at the end, you want to touch the tip of the pipette to the side of the container to get that drop off, but there's always a little bit of water left in the tip that it's calibrated to be left in there. As long as there's not an actual drop protruding from the tip, you're good. All right, so in the lab, you're going to have to read the, well, you guys aren't in lab, but you're going to read then for me the level of water in the graduated cylinders. So let me rotate that around so you can see the numbers. And using the right significant figures for this particular measuring device, and if you don't know what that is, please make sure you're reading through all the material in the lab handout, and you should read the volume then from this graduated cylinder. I'll put my hand behind that if that helps you visualize the meniscus a little bit better, or maybe not. Either way, you should be able to make a good reading off of this graduated cylinder. All right, now next we're going to measure the mass of this graduated cylinder. So coming back over to our balance, let me zero, even though it does say 0 right now, but I'm going to hit this tare button again. Oh, it's not saying 0, so let's try this again. There might be something that's evaporating off of the pan right now that's causing it to lose a little mass. See the negative sign over there? Okay, that looks solid. That looks steady. And there's the mass. See if you don't, hopefully there's no glare there and you can read the numbers. There's the mass of the graduated cylinder plus the water from the pipette. Okay, with all that information then, you should be able to complete that portion of the lab. Again, you're only doing 1 trial because my memory storage, doing 3 trials of the video gets too long, so you're kind of lucking out today. And we'll move on to the next part of the experiment. Okay, here we have a volumetric flask. It's a 50 milliliter volumetric flask. So it's calibrated to contain 50 milliliters of liquid. So we're going to see if that's true by again measuring the mass of water and its temperature and using the density, compare it to the volume that's actually on this flask. So we're going to first of all take the mass of the flask. So let's come over here, and we see that the balance is tared out, it's zeroed out. Take the mass of the flask. And that's, the G is popped up, so that means you can record that mass. It looks like the last digit has a little bit of wander. That's normal. Remember, that's an estimated digit. So it looks good there. That's a good mass measurement. So let's take that away. And now we're going to fill the volumetric flask. So here, looks like that's good and good range for you. Here's the water we're going to fill it with. Normally a volumetric flask has a cap to it, so if you're making an actual solution where something is dissolved in water, you would put the cap on and mix it up to make sure everything's homogeneous. We're just using water, so we don't really need to do that. So I'm just going to leave the cap over there. You'll see in the next experiment a making of a solution inside a volumetric flask. So I'm going to use, oh shoot, I had a funnel over here. Well, I don't need it, I guess, necessarily. I brought a small funnel over. Oh, here it is. Ta-da, it was in my pocket. Anyway, that's not exactly the most non-contaminating area to put a funnel, but it is what it is today. So there's a funnel to help us put the liquid into the volumetric flask. So I'm going to go ahead and do that. Now what you want to do is notice where the mark in the neck is on the flask. And it's a faint mark, probably kind of hard to pick up in the video, but there it is. And I'm going to want to make sure that I don't fill any of the liquid through the funnel further than the bottom of the neck, because otherwise it's really quick to go past that mark. Now, because this is a pure substance, it's not going to be really super critical that I hit the mark on the first time, because I can just dump a little out and then bring it to the mark. But when you're preparing a solution, you typically only have 1 shot to get it, because you've got a substance that's dissolving already inside the volumetric flask, so you got to hit the mark exactly on the first time, or you have to start completely over. So I'll hit the mark on the first time, I'm not worried about it. Let's go ahead and start putting the liquid in. And again, I'm just going to fill it up to the bottom of the neck. And when I'm at the bottom of the neck, I'm going to want to switch to a different delivery device. So make sure that you've got everything from the funnel in there. Then you can use a little wash bottle, a little squeeze bottle to top it off, or I'm going to be using a plastic pipette dropper. So I'll do this and I'll get down nice and even so I can see my mark. And you just add it bit by bit, one drop at a time towards the end until the meniscus is sitting right on top of the line. You don't want to overshoot again or it's kind of ruined. Okay, so that's set. That's got supposedly 50 mils. Now you do have to look at it and make sure that you don't have any air bubbles. So air bubbles are going to take up extra volume, right? So I'm looking at it, and that's where the topper might come into play, because then you can get the air bubbles out as well. I'm not really seeing any, but just in case, I'm going to go ahead and put the topper on and let it make sure that any air bubbles down here are going to be in the head space up on top of the liquid. Now I'll check to see if I lost any volume, and I did lose a little bit of volume. Right now the meniscus is sitting slightly below the mark, so I got to be very careful because it's very slight. So I'm going to add just a smidgen more, you know, just maybe a fraction of a drop if I can manage it. Ugh, that one didn't go down. So let's see if we can get that off the neck. Again, you don't want any water droplets in the neck either. You got to really watch, because if there's droplets still clinging to the neck, they can come down and change your volume reading. Now this volumetric flask must be slightly dirty, because you can see that there are water droplets clinging to the neck. Now that's going to affect things, because we want all the volume to be down in here. It's not draining perfectly, which means it's not perfectly cleaned. So if you were working in a very careful laboratory setting, you would have to exchange this for a more clean piece of glassware. But we're not going to worry about that. It's actually sitting right on the mark now. Now there are extra water droplets in the top of the neck, so let's see how that affects our calculation. That will be interesting to see. So knowing that I didn't measure it with the cap on, I have to take the cap off. So let's go over then to the balance, and we see there's the balance at 0. I'm going to go ahead and tear it again and put this on, and you'll see the mass coming up. There's the G, so you can go ahead and record the mass now. There's really no wander this time, so that's a good number. And lastly, I'm going to go ahead and take the temperature of the water. I'm going to pour a little bit out because I don't want it to overflow as I take the temperature. I could take the temperature of it in the beaker too if I want. It shouldn't be any different. But let's go ahead and put that in there. It's probably going to be the same as we saw for the pipette, because the water all came from the same source. But it might have warmed up a little out in the room, or who knows. Okay, so take a look at the thermometer. Try and here, let me move my hands a little bit so I don't impede your view. And there is, I think that's a Celsius. I can't really see very well, so I'm hopeful that's a Celsius and you can see the marks right there, because I think that's the Fahrenheit. Yeah, those numbers are bigger, right? Okay, and make sure again you're recording with the right number of significant digits. All right, so that's that. We would be doing it in triplicate again if we were in the lab live, and I did do that originally and I lost all the videos, so I'm only doing it once. So you should be able to finish up those calculations, and you'll only have one trial on your report form. So this last part is the proper use of a Buret. Like the volumetric flask that I showed earlier, this Buret has already been used today, and you might notice that if you can look closely, that there are some water droplets clinging to the sides, in which case if you were doing very careful work you would not want that to be there. and you'd want a little bit cleaner, fresher Buret to start with, but we'll see. Because we are going to rinse through the Buret, we might be able to see that the water droplets are not going to be of consequence to us, and we're going to move forward anyway. We are going to be dispensing liquid into an Erlenmeyer flask because Erlenmeyer flasks are typically used for titration. This Erlenmeyer flask also looks a little dingy, but okay, we're going to move forward with it. The Erlenmeyer flask is used with a Buret often because a Buret's used for titrations. In a titration, you're doing a chemical analysis based on reaction of a substance inside the Buret with a substance inside an Erlenmeyer flask. The conical shape of the flask allows you to swirl and combine the reagents without spilling them, so they're very nice. You don't necessarily need an Erlenmeyer flask for this because all we're going to be doing is dispensing water from the Buret, but we're using one anyway. So let's go ahead and take the mass of the Erlenmeyer flask. So we come over here. Again, we want that to read 0. It read 0 anyway, but I'm kind of obsessive compulsive about always zeroing it anyway. And here is the mass of your Erlenmeyer flask. Empty, empty. There's the G. Everything's looking pretty stable. A little hop in the number there, but nothing significant. Remember, there is uncertainty in that last digit, so a little bit of water like we're seeing is not a big deal. If you wrote down a 6 or a 7 or an 8, it's not going to significantly impact your final result. Now you still should write it down, but again, there's going to be uncertainty there that we're carrying through the calculation, and that's fine. Okay, so here we're going to first of all fill our Buret to get ready to dispense the liquid into the weighed Erlenmeyer flask. So I'm going to use a funnel at the top of the Buret in order to easily dispense the liquid or put the liquid into the Buret. Now you want to double check and make sure that this valve called a stopcock is closed before you start this, or you're going to have a mess. Either that or you have to have a catch container underneath. But when you're rinsing it, you definitely want this closed first because you don't want water, you don't want the liquid to just rush through and empty out immediately. So we're going to, I'm short, so I'm going to put this over to the side and lower it down. And here's the, let's lower it down so you guys can even see the top. Here's the liquid I'm going to be pouring in, just water. And we're going to first of all rinse the Buret. So we let the liquid go into the Buret and it washes down nicely. If it's clean, we don't see any droplets clinging to the sides. Now at the bottom I do see some droplets clinging, so our Buret is not perfectly clean. Now we're going to go ahead and drain that. So we put a little waste beaker. Let's see, I'll raise that up so you guys can see that at least a little bit. There you go, we're just going to let her drain out. And I open up the stopcock and the liquid drains out. And sometimes, because the hole in here is pretty small for drainage, there's not enough liquid up above to kind of force it down through the hole, and you don't quite get complete drainage. It's usually of no consequence as long as it drains below the 50 mark here cleanly, and this one drained perfectly, so it's not coming into issue here. Alright, so you would rinse it out. At least we just did it once, but 3 times is a really good amount to rinse it. Rinse it maybe once with water and then 3 times with the solution that you're going to fill the Buret with. Now we're just filling it with water, and it's already only had water in it today, so I'm not going to rinse it again. I'm going to go ahead and close the stopcock again. Lower the Buret because I'm going to fill it. Notice that the funnel is still at the top. Flip this up a little so you can see. Yep, the funnel's still there. So I check again to make sure that the stopcock's closed, and this time I'm going to fill the Buret. Now, when you fill the Buret, I have a nice small funnel here, and it's perfect. But if you have a little bit bigger funnel, sometimes as you put the liquid in, it goes in quickly, but up here it's slow. Kind of slows the flow down, so you think there's less liquid than you've actually dispensed into the funnel. So what can happen is, as the liquid drains and you think you haven't added too much, you really have, and it comes up and over the edge and it's a disaster. So you've got to be careful and really watch it, because it is very easy. I've seen students do this many, many, many times, where they'll put the liquid in the funnel, and then as it drains out the funnel, they put too much. Whoop, overflow it goes. I'm not going to demonstrate that to you today. I'm going to demonstrate how to do it properly. So I'm going to fill it until it's maybe just a little past the 0 mark, but as I get close to the 0, I'm going to slow down so that I do not accidentally overfill it. So there, slow down, and it does it. It surprises you. It fills up a little bit more than you think it's going to. So, oops, I almost did overflow it. Woo, close. Wasn't that close? See, it was because I spoke too confidently earlier. So it's well above the 0 right now. As you know from watching the video, Burets read from 0 at the top to 50 at the bottom. When you read the Buret, you just read the number. You don't try and adjust and make a calculation to see how much liquid is inside the Buret. The idea is to determine how much liquid the Buret has dispensed. So you just read the number directly. Typically, traditionally, when you read a Buret, you write the initial volume underneath the final volume, and that way you just do a subtraction to figure out how much volume you have dispensed. Now I'm going to have to get my volume level at or below that 0 mark. Plus I have another situation. If you'll notice, I have air in the tip of the Buret. I can't have any air there. I can't have any air bubbles above either. So I'm going to drain some from the tip, and I'm going to drain it so that I'm either at or below 0. And I don't really care about being exactly at 0. Some students get really obsessed with that. No reason to. It doesn't have to be exactly at 0, but between the 0 and the 1 milliliter mark is a good place to start typically. So I'm just going to dispense some to make sure there's no air bubbles. And then I'm going to check to see where I'm at the top. Well, I'm not below the 0, I'm above the 0 still. So I'm going to drain it out until it gets to around the 0 and then stop it. Now at this point, we're going to go ahead and read the Buret. So you should already know how to do this, having watched the demonstration video. So I'm just going to give you a close-up so that you can read the Buret yourself. I'm going to lower it so I can do it even. Wow, okay, that's not too bad. So here is the Buret. I'm going to twist it around because I think when I did this before, reading it against the bricks in the back, that white made a really good visualization of the meniscus. Let me just twist it a bit so you can see the gradations on there. Now, I got a really bad ring stand, so let me make sure it's steady. And you need to read that the way that you were demonstrated to read Buret in the video, and the way that the lab itself procedure tells you to do it, okay? So that's your initial volume. Remember, the numbers get bigger as you go down, so your final volume should look bigger than your initial volume. All right, so the instructions say to dispense about 15 milliliters into that Erlenmeyer flask. So we were pretty close to 0 on that initial reading. So if I bop down pretty close to 15, that should suffice. It doesn't have to be exact. We just need to know how much we dispensed, and I'm just want you to do roughly 15. So I'm going to go ahead and open up the stopcock and let the liquid drain until it gets to around 15. Then I'm going to stop it and let you read the volume again. Okay, and sadly, because of the way I have the camera, you probably didn't see the water go down. It's not that exciting anyway, I'll be perfectly honest with you. So the next lab video is exciting, I promise. Here is then the second volume. Again, let me put my hand behind it a little bit, helps you visualize the meniscus a bit. If you can read the numbers, I don't think the gradations are quite in your view, so let me twist it a bit so you can see. Hopefully this is reasonably good camera work. I won't know until I look at the video, and there's not a chance I'm doing this again. So, well, I shouldn't say it like that. very little chance that I would even fathom doing this again, as much as I'm having fun. Okay, so there's your number. So write that down correctly with the correct sig figs, and that's the amount of liquid that we dispensed into this Erlenmeyer, the difference between our initial and our final. So let's take the Erlenmeyer back over to the balance, and there's our balance at 0. Here's the Erlenmeyer with the liquid in, and let's wait for the G to pop up. There it is, and the digit's wandering a little bit. Again, if you have a little bit of residue on your fingers, you really shouldn't handle the glassware directly with your hands if you're being super careful. The residue on your fingers can get on the glass and add weight that can evaporate over time, causing some not random travel in that last digit. See how it's losing mass? That possibly is what could be happening here. If you wait too long, the water itself will evaporate. That takes a while, but you shouldn't linger too long over the balance. Now it's wandering enough that I'm a little concerned. This happened with an earlier shoot that I had to discard. So I'm going to re-zero it because I feel like something might be happening. And I notice when the blower's on, the furnace in this room, that it does have a little bit of an impact on the stability of the mass readings for whatever reason. Disruptions in the air, even though it's isolated with this box here, it still can maybe, I think, disrupt it a little bit. Okay, that seems a little, I spoke too soon. Okay, that's more stable. It's not moving as quickly. I would go ahead and, oh geez, of course, I'm speaking too soon. And I'm still losing weight, dang. I like it to kind of hold a number for at least a few seconds. Looked like we almost had it there. All right. I'm going to try one more time. Give it a chance. So I ran into this a little bit earlier today, and it was while the blower was going, and it's still going. I don't really have control over that. That's the environmental comfort, is the furnace, or we have a boiler in this building, but to heat the building. And it is forcing the air in the room, and I think you can even see with zeroing it that it's not holding that last digit. One more time. If this were an analytical lab, everything would be vibrationally isolated. It is air current isolated, but these are pretty sturdy desks that they're on, but it's not, I don't think, 100% at a level you would see in a very clean lab where everything's being very carefully measured. Man, it still wants to drop. Okay, we're going to take it there, okay? That's pretty long, that's pretty good. So we're going to call that's the mass that you're going to write down. And then you can move on with the calculations from there. And that then concludes the measurements lab. Again, you kind of got off a little bit easy because we're not doing it in triplicate for you guys, but you'll have to answer a few additional questions that you'll see in your report form that the on-campus students are not doing. So if you have any questions, by all means, please message me.